All right, so we're skipping over section 5.6. We're going to 5.7. So scatter plots are just a way of plotting points of data. So we're graphing a set of data. So you have something and you're measuring something that's happening, and you come up with points that represent that thing, and you make a graph of those points. That's called a scatter plot. Usually, not always, usually in the first quadrant. And that means our graph usually looks like this, and we're here. This is the first quadrant. And well, that also means that our x and y are both positive. So usually scatter plots have to do with positive numbers. Not always, but usually. Now, scatter plots are useful because they can help us see trends in data. What is happening? Do things get bigger or do things get smaller? Do the things seem to be related in any way at all? There are three main types of relationships. So trends or relationships. So this is just how we describe how the data seems to be related to each other. I'm going to draw some pictures to describe the three types. The first way is if we have something like this, and we plot our points, and our points look like this. More or less. When our data looks like this, we say there is a positive correlation. When it looks like the graph goes uphill, we say it's a positive correlation. And that means y goes up as x goes up. As x gets bigger, y gets bigger. Our graph goes uphill. If our data looks like this, something like this, where the graph seems like it's going downhill, we say this has a negative correlation. And that means that y goes down as x goes up. As x gets bigger, y is getting smaller. We call that a negative correlation when the graph goes downhill. And then the third main type is if our data looks something like this. our data looks like that, we say there is no correlation. It seems like the data is not related. So this could represent if we collected data of the position of wadded up pieces of paper versus the trash can there in the middle. That would be a negative correlation in this class. Same with my other algebra class. So there's a negative correlation between the position of the trash can and where the paper ends up, seems like. All right, so positive correlation, our graph looks like it goes uphill. Negative correlation, our graph looks like it goes downhill. No correlation means that it looks like the data is random. There's no relationship between the two at all. All right, so we're good there. Okay, let's talk about how we construct a scatter plot. It's super easy because we really already know how. So let's say we collect some data over how long a student studies and the grade that they get on a test. So we collect this data, and if a student studies 7 hours, 88, 3 hours, the students get a 79, 5 hours, 92, 1 hour, 71, 0, 62. That might be a little generous there. 6 hours, 94, 4 hours, 82, and 2 hours, 65. So to make our scatter plot, all we do is think of this first column as the x and the second column as the y, like we always do. And we just make a graph of these points. So I'm going to say this is time and this is grade. Now we need to get an appropriate scale, a good scale. Well, for our x-axis, the time goes up by 1. So I'm just going to label my axis by 1s. Yeah, that's the time. So 1, 2, 3, 4, 5, 6, 7. And our grade, I'm going to go by tens on my grade axis. So 10, 20, 30, 40, 60, 70, 80, 90, 100. That seems like a good scale to use there. And then I just plot the points. So 7, 88, that's going to be up about here. 3, 79, that's going to be about here. 5, 92, it's going to be about there. 1, 71, about there. 0, 62, right about there. 6, 94, about there. 4, 82, and 2, 65. There would be a plot, a scatter plot of that data. I'm just plotting those points on a graph. So here's my scatter plot. And they call it a scatter plot because there are points scattered on the plot. How would we describe this relationship? Is it a positive correlation, a negative correlation, or no correlation? Yeah? It seems like it's positive. It seems like, in general, the data is going uphill. Not 100% of it, but most of it. So I'd describe this as a positive correlation. And the correlation doesn't mean that the data, 100% of the data goes uphill, but in general, most of it goes uphill. Most of the data here goes uphill. Well, another way to describe this relationship, or to describe it a little more accurately, is using what we call a trend line. And a trend line gives us a more accurate picture of the data. It's a line that seems to represent the data. It's a line that is close to most of the points. So it doesn't have to be close to every single one of the points. We want it to be close to most of the points. So if I go back and I add a trend line here, I'm going to do a dotted blue line. Usually for our trend lines, we want as many points to be above the line as below the line. So it's close to most of the points. So I would say my trend line looks something like this. We have some points above, some points below. That would be the trend line. That represents, that's close to most of the points. And if I go back one page to these others that I drew, my trend line here would look something like this. My trend line here would look something like that. This, there's no correlation. So the trend line is close to most of the points. It seems to represent generally what the data is doing. All right, so does it make sense what we mean by a trend line? All right, so let's look at how we find a trend line from a set of data. So we're going to do something similar to this. So let's say we're doing some kind of study of the population of some animal in a habitat. And we're going to have the year into the study. So 1, 2, 3, 4, 5, 6, 7, and 8. And we count the population at the years, this many years into our study. So at 1 year we get 1260, 2 years 1375, 3 years 1310, 4 years 1490, 5 years 1625, 6 years 1680, 7 years 1740, and 8 years 1715. So there's our data that we collected. Now we'll make our scatter plot. So this is our population, and this is the year. I'm going to label the x-axis by ones. And these are pretty big numbers. I chose to label my y-axis by 500s. 500, 1,000, 1,500, 2,000. we'll plot our data. So 1, 1260, something like that. 2, 1375, maybe here. 3, 1310, we went down a little bit. 4, 1490, so we're up a little bit higher. 5, 1625, so up here. 6, 1680. 7, 1740. And 8, 1715, we went down a little bit. So there would be my scatter plot. Now we're going to make our trend line. What I would do if I had this on a piece of paper is I would grab a ruler and I would lay it on the line and adjust it and say, okay, I want it to be close to most of the points, and that looks pretty good to me. So then I would make my scatter plot along the edge of the ruler there, like so. Sorry, my trend line. And there's my trend line. Well, from my trend line, I have a couple of points that I can estimate to be on the line. So I could use this point and this point. And I can say this is x1, y1. And I can say that point is x2, y2. I have 2 points that are on my trend line. I can use those 2 points to find my slope. Well, this point is here. That's 1490. And this point is 5, 1625. So I can use those 2 points to find my slope. So I'm going to do that. The slope. y2 minus y1. 1625 minus 1490 over x2 minus x1. So that's 5 minus 4. So when I do that arithmetic, 1625 minus 1490, I get 135. 5 minus 4 is 1. So my slope is 135. Now I can write my equation in point slope form. Y minus blank equals the slope, 135, x minus blank. And I'm filling in the blanks from one of these points, just like we always do. I'm just going to pick the first one because the numbers are a little smaller. Y minus 1490 equals 135 times x minus 4. And there is my equation for the trend line. Yes, this is a minus. Y minus and x minus. So now we have an equation of our trend line. And we can use this equation to make predictions. So the problem might say estimate the population in year 12. So what this is asking us to do is plug in. Year is our x coordinate. This is x and y. This is asking us plug in x equals 12 into our equation of our trend line. So I would have y minus 1490 equals 135 times 12 minus 4. So y minus 1490 equals 135 times 12 minus 4 is 8. 135 times 8 is 1080. And I'm going to add 1490. And I get y equals, these go away, 1080 plus 1490 is 2,570. So we've estimated the population after 12 years to be about 2,570, whatever they are, animals, bacteria, if we're a biologist studying in the lab. So we made our scatter plot, drew our trend line, used 2 points on our trend line to find the slope, used the slope and 1 point to write our point-slope equation, and then plugged in a value into our equation of our line to get our estimate. Now when I did this problem a different time, when I made my trend line, I had 2 different points on the line, and my estimate came out to be about 2,000. So depending on how you make your trend line, your estimate is going to change. Now there are ways to make your trend line more accurate, but that involves using either a fancier calculator or a computer. And the computer or the calculator will do specific calculations to get the line as close to the data as it can. All right, questions? Okay. Our homework. This is section 5.7, page 341. A through 18 either. Now, not all of these problems are finding the equation of the trend line. Some just ask you, is it positive correlation, negative correlation, or no correlation? Some just ask you, are these things related? I think just one of the problems asks you to find the trend line and make a prediction.